Hello and welcome to this quick presentation on understanding resonance. My name is Jason Tranter, the founder and managing director of Mobius Institute. Mobius Institute provides vibration training and accredited certification. So, resonance is the silent killer inside every machine and structure. Resonance is the excitation of a natural frequency. Resonance amplifies vibration, and that vibration could come from unbalance, or the pump vane vibration, or it could be bearing vibration. Any source of vibration can be amplified. And that amplified vibration can cause welds to break, it can damage foundations, can cause bolts to break, it can accelerate bearing wear and damage other parts of the machine, and it can increase the vibration in general, which can cause noise, therefore affecting the workplace. It can make it uncomfortable for workers in the area. It can reduce product quality. It can even annoy neighbors living in the area of the plant. In this particular photo, this handrail has been vibrating due to resonance and worn this area of the post away. Now, that might not be so severe, but you can see what resonance can do. So, to explain resonance further, imagine we had a tuning fork, and that tuning fork was there for the note A, and its frequency was 440 Hertz. If you attach it, just hold it against a motor, for example, it won't vibrate if the motor is not running. If the motor was running with a little bit of vibration, but not at a frequency that matched that 440 Hertz, it would vibrate just a little, just a little bit. It's just going to vibrate just like the machine's fighting. It's a metal thing, so it's going to vibrate. However, if the machine was running at 440 Hertz to match that tuning fork, the tuning fork will vibrate like anything. The 440 Hertz is the natural frequency of the tines, that's these things, the tines of the tuning fork. And if we excite those tines, either by impacting them, hitting it against something solid to make it ring, or just by the machine generating vibration at its natural frequency or near its natural frequency, those tines will vibrate. And that's the vibration we're concerned about that's causing equipment to fail or noise and all the other things I just mentioned. And one of the key points is that if there is vibration within about 15 to 20% of that natural frequency, in this example 440 Hertz, then we will cause a lot of extra vibration. It amplifies the vibration as much as 10, 20, 50 times as much vibration. It's really quite dramatic. So have a look at this animation, brought to you by military.com, of a helicopter. Now in this particular case, you can see that the helicopter has landed. It's actually held down there, and it's slowly running down in speed, and it's exciting a resonance. It's actually called a ground resonance, but watch what happens. So you can see just how much extra vibration there is, which is obviously damaging the helicopter. Wouldn't want to be on that helicopter. So, pretty dramatic stuff. In a more realistic case in our industrial plants, as the speed increases and gets close to the natural frequency of this crossbeam, you saw that it started vibrating, started resonating, and if the animation just stopped at that point, so all day long this could just be bouncing up and down and doing any type of damage. In this case, again, we got the speed increasing until we happen to get close to the running speed. That's 100% of speed. And in this case, it's the belts that are resonating. It's just exciting. It's not just the belts flapping, which they might flap if they were loose and for different speeds. That's them resonating, kind of like a guitar string. If you plucked a guitar string, it would vibrate like that. In this case, which is quite a common situation, the base of the pump is has a natural frequency which is close to the running speed of the machine. This is very common, and in this case we can see the pump and motor bouncing up and down, which is causing all that extra vibration. Now, exactly how it bounces up and down, or whether it rocks from side to side, that's a whole different story, but this is just there to sort of illustrate what resonance is. So, in conclusion, resonance, the term resonance, is the excitation of a natural frequency. Natural frequencies exist in all mechanical structures. So every machine in your plant does have multiple natural frequencies. A natural frequency might cause it to rock from side to side, to twist, to bounce. There's all sorts of different modes, as they are called. And if your machine just happens to generate enough vibration near one of those natural frequencies, then all day long that structure will rock or bounce or twist or whatever's happening. That's putting a lot of extra stress on the machine. It is common for the vibration of the machine to generate vibration at a frequency that excites the natural frequency, as I just mentioned, and the increased vibration can result in premature failure, high vibration that affects workers, product quality, and other things. So, it's a very important thing to understand. It's something that's not often understood within industrial plants. You can just have failures that you can't quite explain, but this is actually the root cause. So, thank you very much for viewing this presentation. I hope it has helped clarify some points associated with resonance. If you have any questions, please contact us.